We're now ready for number 4 and number 5 of section 5.4. Number 4, the beginning is rather routine, I hope by now, and I only get questions on the second part. So, the heights of fully grown trees of a specific species are normally distributed, which you would expect because they're heights of things that are grown in nature. They have a mean of 56 feet and a standard deviation of 7.25 feet. Random samples of size 15 are drawn from the population. Use the central limit theorem to find the mean and standard error of the sampling distribution. Then sketch a graph of the sampling distribution. The mean is the mean is the mean. So the mean of the sampling distribution, mu sub x bar, is the mean of the population, or 56.0 feet. The standard error of the sampling distribution, sigma sub x bar, is the standard deviation of the population, sigma, which was 7.25 feet, divided by the square root of the sample size. So we're going to take 7.25 divided by the square root of 15. And we get 1.87 feet. That's going to be the difference on the axis between the marks. So let's throw out what we can throw out first. Okay, 56 to 63, that's a difference of 13.3. That's not going to be the one we're interested in, because we need a difference between these. Our first hatch mark would need to be at 57.9, 56 plus about 1.9. Let's throw this one out just to make sure. 0 to 1, this is the standard normal curve, so it's not going to be that one. But the correct answer is B, 56, 57.9. So that's what you're looking for in that answer. We started out with the normal distribution, so the shape of our sampling distribution will also be normal. Number 5. The mean height of women in a country is 64.3 inches. They take a random sample of 50 women in this group. What is the probability that the mean, watch for that word, height for the sample is greater than 65 inches? Assume sigma is 2.97. So the TI command line, and I wrote it down this time just to make sure that you had it, is normal CDF. And remember that second bars, number 2. And we're going to start at 65, comma, and we're going to go up to second comma EE, 99. Our mean is 64.3. The mean and standard deviation and sample size in your problem will be different as a rule. And then you might be lucky. 2.97. We want the standard error, so 2.97 divided by the square root of the sample size, which was 50 women. And we get a probability of about 5%. Now, what if it asks what's the probability that an individual woman was taller than 65 inches? What would be different? Well, let's look at it. Our command line is going to be almost the same. The difference will be that we are not going to divide by the square root of 50. We could divide by the square root of 1, but the square root of 1 is 1 divided by, any number divided by 1 gives us the same number. So we're just going to get rid of all this because we are not talking about the mean. We're not talking about a sample in the question. An inner, and it's pretty common. But the mean of a whole bunch of women, they're not going to be on average that tall. So be careful when you read these. Watch for those words mean and sample.